Hi, I'm Kajal Sharma. I'll be covering the application and storage component of our AWS Financial Application Solution. This component addresses all services required by the Platform as a Service model to securely store and deliver data within the application. So to account for the application module, I used AWS EC2, Autoscaling, and CloudFront integrated with Amazon Kinesis and SNS. Similarly, storage comprised of AWS S3, EBS, S3 dPlacia, RDS, and QLDB. I will now showcase these configurations, starting with Amazon S3. AWS S3 offers a highly scalable and reliable fast data storage facility with low costs. A bucket has been created in the Asia Pacific Sydney region with an object to represent the Financial Applications Index page. This service has been configured to have bucket versioning, default encryption, service access logging, transfer acceleration, and request to pays enabled. Static web hosting in this case redirects all requests to the registered domain. Inventory configurations have been set up to go through the objects in this bucket on a weekly basis and return a report outlining all information covered by these fields. Encryption has been enabled with the customer managed key. While all public access to this bucket has been blocked, a policy has been defined to allow the inventory configuration to access stored data. To ensure the recovery of all log files, S3 Log Delivery Group has been assigned the read and write roles. This course configuration enables the S3 bucket to interact with the web application supported by CloudFront. Finally, an access point has also been established in conjunction with the VPC for this bucket. A lifecycle rule has been created to delete expired object delete markers and multi-part uploads after 365 days of being stored. Additionally, all data with previous versions should be transferred after 30 days of becoming non-current to S3 dPlacia. All archived data will be stored in the S3 Glaciers web app vault. Amazon EC2 offers a scalable data computing capacity to develop and host a financial application. As visible, two EC2 instances have been created with the T2 microtype and have been arranged to sit in both availability zones. Monitoring of these instances have been enabled. This service also allows for the configuration of relative security requirements through security group and key name. All instances have been placed within the application's VPC and are attached to the corresponding subnets. These EC2 instances are supported by EBS storage volumes that promise high availability and reliability. The EBS storage volumes are encrypted with the customer managed KMS key. EBS snapshots are also utilized to create copies of data against the time series for disaster recovery situations. An auto-scaling group has been created to allow for the automatic scaling of EC2 instances. Here, the desired and minimum capacity have been given equal values of 2 to ensure at least 2 instances are running at a time in the relevant availability zones. Here, I've also defined that during busy periods, auto-scaling can only create a maximum of 10 instances in total. Corresponding subnets and target groups from the load balancer have been attached to this group. We can also see that upon any action taken by this group, a SNS notification is sent to the Web Operations Admin team. The use of CloudFront accelerates web content distribution. It is configured to use the S3 bucket as the main origin with a managed caching optimized policy. The registered domain name has been fed as an alternative domain name. Logging has also been enabled for both standard and real-time logs. Field level encryption has been set up for this service, secured by a public key. Amazon Kinesis is another service introduced to stream all event data collected by CloudFront. A MySQL-based RDS database has been set up for this design with deletion protection enabled to minimize accidental data alterations. Permitting multi-availability promises data redundancy. CloudWatch has also been granted permission for monitoring. As can be seen, regular maintenance and backup windows have been set up for point-in-time recovery purposes. QLDB is another storage service incorporated to host immutable transaction logs. Encryption at rest has been enabled to secure all data. For demonstration purposes, this ledger has been autofilled with sample AWS data. QLDB is also connected with Amazon Kinesis for data streaming purposes.
The part that I'm going to present today is the configurations related to the networking component. There are 4 AWS services in total that are in this component, which are Amazon VPC, Amazon ELB, AWS WAF, and Route 53. Amazon VPC is included in the design for securing our financial web app and other cloud resources. It allows us to logically isolate our resources in the cloud and have more control over how we want the permissions and traffic flow to be like. Here I have a VPC configured in Asia Pacific Sydney region with a name that we can easily identify when we configure other components, and with VPC IP range specified to be this one, and we can see that this is successfully configured. Within this VPC, there are 4 subnets in total. Public subnet 1 and private subnet 1 are located in the same AZ, and we can see that the private subnet 2 and public subnet 2 are located in another AZ. With 2 subnets implemented in each of the 2 AZs, we can we're able to ensure redundancy and fault tolerance. Additionally, you can see that the subnet IP range is within the VPC IP range specified earlier in the configuration for VPC. An internet gateway was configured and attached to the only VPC that we currently have. Its route was added to the custom public route table created so that the traffic can flow from internet gateway to our financial web app in the public subnet. So the details of the routes and subnets can be seen here under the routes and subnet association for the public route table. A net gateway was added in public subnet 1 so that traffic can flow from public subnet to private subnet, from private subnet to net gateway and to the internet eventually. Similar to internet gateway, a route to the net gateway was also added. And also, private subnets were configured to be associated with a private custom route table. Since the VPC was opened up to internet traffic, network ACLs and security groups need to be in place to secure our resources and network. Network ACL is considered to be firewall at subnet level, whereas security group is like firewall at instance level. The default ACL was configured from allowing all traffic in and out of any subnet to the following. And we can see from for public, the inbound rules, we include allow all HTTP and HTTP traffic as traffic to public subnets. And for outbound rules, an example would be to allow outbound MySQL access to database servers in private subnets. And then for private subnets, the inbound rule would be allowing web service in public subnets to read and write to database servers in private subnets. And the outbound rules is consistent with the configuration in E2. And for security group, there's one specifically for EC2 instances in the public subnets and another created for ALB, enabling inbound rules for HTTP and HTTPS protocols to allow web requests. Unlike network ACL, security groups block all inbound traffic and allow all outbound traffic by default and are stateful, so the allowed inbound traffic are able to flow out to respond to users without explicitly configure outbound rules for security groups. And Route 53 is included in the design so that we can route traffic to use and share resources. A custom domain was obtained as shown here, and an alias record was also created in the public hosted zone for DNS to route traffic for the domain. AWS ELB is included in the design to load balance HTTP and HTTPS traffic to financial web app instances that we have. The specific ELB type that was chosen is application web load balancer. It's attached to VPC, AZs, and security zones that we mentioned earlier, and it is internet facing with listeners on port 80 for HTTP traffic. Additionally, a target group was created in the process which helps with routing traffic from load balancer to the EC2 instances created by Kajal. AWS WAF is partially included in the networking component in terms of the configuration for web ACL. It is associated with the web to the ALB, and any request that doesn't match with rules in the managed rule groups will be blocked by default based on the configuration.
Hello everyone, my name is Matt and I'll be going through the security and auditing component. So for security, we'll be looking at AWS Services Security Hub, Guard Duty, Shield, Inspector, Firewall Manager, and WAF. where Security Hub will act as a centralized point for a lot of these applications, and Firewall Manager will manage the rules for the WAF. For compliance, we have AWS Artifact and Trusted Advisor. For authorization and access control, we'll be using IAM, Key Management Storage, and Cognito. For auditing, we'll be using CloudWatch and CloudTrail. So if we go to the services, we've got AWS Key Management Service here. So we've got, ignore the first key, sorry, I made a mistake on that one, so that's been disabled. We've got an admin key here. This is the key ID. It's enabled, and we're using the RSA 4096 spec for encryption and decryption. 4096 spec will be the most secure, but has more of a potential for latency, which is more important to be secure in a financial service application. So if we go here, the key administrator is admin and the key user is admin, because of course this is the administrator's data. Now for user pools, we've got a consumer pool and an employees pool. So for the consumers, we can see here users can sign up themselves. Password minimum length is 8 characters, and it's got to have all the different options available. This is what they are required to sign up, and that's the primary difference. It's got between that and the employees, and it's got multi-factor authentication as both of them do. So if we go to the employees, we'll see the difference. So only administrators can create these users. That's pretty self-explanatory for employees versus a consumer. Okay. We'll move on to IAM. So for IAM, we'll look at some of the user groups. We've got administrators, cybersecurity team, database technicians, network team, support desk, and web operations. Obviously, they're just examples in here at the moment for the users, so there isn't too many. But for an example, we'll go into one of them, cybersecurity team. We've got a specialist there. For the permissions, we've got read-only access to all the different stuff like CloudWatch, GuardDuty, all the cybersecurity related services. Go to roles. We'll go down here. We've got all the different roles that are appropriate for the different services we're using. Then we've got the cybersecurity administrator, database administrator, network administrator, security auditor, support officer, and web ops administrator. So for an example, if we click on the network administrator, so he'll be part of that user group, the network team, but he's also got the policy name attached, network administrator. Okay. So if we go to the firewall manager, we can see here, we've got a web application firewall policy. If we click on that, go to the policy details. Oops. There we go. So we've got the different rule sets that we've set out. So we've got a core rule set for security actions, known bad inputs. That's especially important with a web application. We're using Windows operating system. So we've used up all the ACL capacity. That's pretty much it for the non-network side of the web application firewall. Here we go, we've got the Security Hub. So the Security Hub, we've got two different standards here, the CIS AWS Foundations Benchmark and the Foundational Security Practice 12. We've got AWS Shield, so I'm not going to click on subscribe to Shield Advanced because that's all you have to do, and then it will cost money. But that's it for AWS Shield. Just clicking on that button. Amazon Inspector is the same, so it will be used for analyzing AWS services. So you just click Get Started. Okay. For CloudWatch, we've got 3 main metrics we're measuring here. So we've got the EC2 CPU utilization, and that'll trigger an auto scaling, horizontal auto scaling at RDS database connections. That'll trigger a notification, and healthy host count will also trigger a notification to the appropriate administrator. For the CloudTrail, we've got API user activity. and that will just be logging the user activity. Trusted Advisor, we've got here, and we'll be using it for cost optimization, performance, and security measures that we can have a look at what we can potentially fix in our system. And finally, we've got the AWS artifact, which we've got an agreement, an Australian agreement appropriate for our services. Okay, thanks very much for watching my presentation.